Hello, Marinas. Yeah, that's it. Thank you.
Done.
Okay. I've been using them for so long that I tend not to realize that there was another way to do it in the olden days. So I tend to assume things. So I'm going to go through this piece of code, if I can find it, it's called prod 000, which was just a name I gave it. And I want to load it here so that you can see it. And I'll go through this line by line. Please stop me and ask questions if there is any doubt about anything. Right.
Is this the test program that it should be into your sample code?
I can put it in. I can give it to you as it is sample code. It was a program I wrote to just try and explain how it's used.
Okay.
So I'm going to make some changes to this as I go along, and you'll see them. And then I can actually pass it across to you as a template, if you like. Okay. But obviously, using something as a template, this varies. The usage would vary depending on the application. As a result, it's more important to understand the principle than the detail of this particular example. Okay. So, because it's a sample program, I actually created a linear mainline. I always do linear mainlines because it gets rid of a lot of hassles. Activation group no, and default and activation group new, i.e. this is going to start a new activation group. Now I do that quite deliberately because when I'm finished with this program, I don't want to have to go and delete things and close things down and shut things down. I just want to walk away from it and have it all closed down for me. It makes my life easier. So that's why I start an activation group new. In this particular case, I would always, in a test program of any sort, I would do that. Here, I'm naming the binding directories that this program should look into to resolve any import symbol requirements. Now, you'll notice I've got two binding directories. One is ABC services, which is the one I've created in ABC train. And the other one is my AO services, which is created in my AO library list. Now, I've put in two. You can put in as many binding directories as you like. But when you're writing code, and remember this is actual program code, when you're writing program code and when you're using this type of thing, I would suggest that you keep to one master binding directory with all your service programs in that one directory. If you start splitting them up like this, and you have more than 3 or 4 or 5 different binding directories for different reasons, it can get terribly confusing as to where you find anything. And my philosophy has always been keep it as simple as possible. It makes life a lot easier. The other keyword I use in my programs is this one. You can look this one up. There's a slight difference between the way the database handles binary fields and the program handles binary fields. Like if you have a B4, for example, defined in the database, it's 4 digits with a maximum of 9999. But a 4 binary or an integer 5 in a program is also 4 digits, but it's a bigger maximum. It's 32767. So this keyword allows your the compiler to treat binary fields in the same way from the database and the program, and it actually matches it up. So that's always in every one of my programs. User profile, of course, is adopting the owner profile. Public authority is use. And I always throw these two in so that I can debug this at any time. No debug, IO debug. That's it. So those are my control options for pretty much every single program I write. So we're not going to worry too much about that. Once you get a standard set, yeah, you copy and paste it. I don't even write it anymore. You could, in fact, put it in a copybook, but not the top part, because you've got that is a variable, but the rest of this part, you could use a copybook, although it's hardly worthwhile. Now, I have no imports for this program, but I have some prototypes. Now, prototypes are a definition of an external link that is required by this program. That's what a prototype is. You're prototyping an external symbol where the compiler's got to go and find this thing. Now, this is the error handler. And I can do this quite simply by just opening it here. This is what I like about RDI. That is the copybook I use. You can see it's got the include statement in as a comment. And then I've got the declaration here. So when I include it as a copy or include statement, it copies those 3 lines in. So my definitions for these prototypes are consistent. That's the point about it. This one here is also the prototype for the command. And this one's slightly different because it has a standalone field declared, which is the command string itself, and then the call to the command with the variable character, etc. So these are prototype declarations which indicate to the compiler that I'm looking for an external call. In this particular case, because both of these are in a service program, they will be bound calls because they're in a service program. Okay, so we can take those out and get on with the next one. Right, now here we come to my definition of the IO servers that I'm going to use in this program, i.e., I've put both of them, our 2 files, prod.ord and from IP7, both of them I've put into this program. The code is actually going to use both of them. Now, this is where, because all the IO servers that I create use a very standard parameter list. They have 3 parameters always. This was designed this way to be consistent. And there, from there to there, is the prototype declaration. It refers to prord string. This here is the return from that string, from that procedure. Now, because the procedure is actually returning a value, it's actually a function. I actually use procedure all the time, but please understand, in terms of the book, the technical book of things, the technical book calls these a function because they return a value. If they don't return a value, then they are called a procedure. Okay. Now, this shows that this is an external procedure, and it has that name. Now, because this name and this name are the same, this is optional. However, I have got into the habit over the years of making this a standard, because what I can do if I want to is I can change this name to assist or to document this procedure in this program while still calling the same procedure name itself. So I could call this IOSP1 or whatever I want to call it. So you can give it a different internal name to its external name. And this, because it's an external procedure, is again a bound call. Now, what I also need, once I've created that procedure definition, is I need 4 other fields for every IO server that I'm using. I need a data structure that defines the key of the file. And we do that with that particular statement there. I call it prod.ord keys. I give it a file name with a K at the end. Its external name is prod.ord. That is the file name. And it has star key, which means this data structure is made up of only the key fields of that file. All data structures I qualify all the time because it helps in terms of the documentation in the program. You have to then use the qualifier name when you name the data name. And that means that you can see where it's coming from. So I've made a habit of using qualifiers all the time for my data structures. Which, sorry? Question. Was there a question? What's happened to the, oh, there you are. I thought you disappeared, but not. Okay. So that is a key data structure. Defining it like this means you don't have to worry about whether the file has 1 key or 7 keys or 10 keys. It just defines the data structure with those key fields in it. Okay. And each of the elements inside that data structure has got the name of the field as it is in the file. I also put in a length, and I initialize it to the size of the record. I like having a record length. I use it for all sorts of things. We'll get to that in the future. And so the record length is a useful thing to have, to know exactly how big the record is. Then what I do is I define, well, put it this way, let's take this one first. There is the definition of the record data structure itself. ORD-R, or what I use this naming convention throughout. Its external name is the product ord again, qualified INZ NDS. That is the statement that identifies the data structure, which is the record from the file. Okay. Again, it's qualified, so I have to prefix each field name with an R, and it's initialized so that any numerics become zeros, alphas become blanks, and everything gets properly initialized, because remember, a data structure by default is spaces. And if you don't initialize it, your numerics have spaces in, so you get decimal data errors if you don't fill them in. So I tend to use that all the time. Now, you'll see the
Tommy?
Yes.
You said that but R is prefixes, and so prefixes with an R.
This is a suffix. Sorry.
Okay.
This is the record. I always use the file name plus an R to indicate that this is the record data structure.
Okay, but the fields within that data structure, were they gonna be prefixed
by
with something?
prod R. If you want to refer to
okay,
one of those fields, it would be prod.r dot field name.
Okay. All right.
Now,
Okay.
the reason I do this is because of a opcode called eval corresponding. Have you ever
Okay.
used that opcode?
I don't know. Not me.
Anybody else? Used eval hyphen EVAL hyphen CORR. Anybody used it? It's a great opcode.
Yes, sometimes.
Yeah. What it does is it moves fields from one qualified data structure to another qualified data structure and matches the fields by name and attribute. So if I wanted to populate this key field, for example, from this record, I would eval corresponding ord K equal ord R, and it would populate only the fields in ord K with the corresponding fields from ord R. It means you can move data structures backwards and forwards using exactly the same names. You don't have to do move. You just move the whole data structure and it picks out the fields that match. Very nice tool, which is why I use the qualified, in addition to the fact that it helps document where that field is coming from if I refer to the field. Okay. Now,
but just to me, just
yes.
one last thing.
Yes.
The prefix right now is kind of this name, but let's say we tend to use a shorter prefix, and any way to rename this and use a prefix with 2 digits for alphanumeric characters?
You're talking about a prefix on a data name.
Yeah, yeah, on a field name.
This is a qualifier for a field name. It's not really a prefix, it's a qualifier. Okay. So I would write, for example, I can't remember what field name is in that file. What was that, the key field in this file?
Was probably order number, or
NOCOM.
NOCOM.
Okay. So the way I would refer to that would be like this.
Yeah.
Sorry, that was not clever.
Okay. But that was just a question. Yeah. It's no problem to use this.
You see, that's the way I would refer to that field.
Yeah.
Because then I know which data structure it's coming from. Absolutely. If I refer to it like this, it's coming from a separate data structure. It's coming from another data structure. So it helps to qualify. And when you've got data structures that carrying the same data names, then of course you have to qualify, otherwise you will get total confusion. Okay. So I tend to make a habit of just qualifying everything.
Okay.
It means you have to type a few extra characters, but it's not too bad. Yeah. Right. So I then do the whole thing all over again for the second file. You can see it's an identical pattern and with the same little letter at the end and the same definitions, etc., etc. So once you've done this 10 times, you will decide that this is very tedious and you need to find a quicker, cleaner, neater, and easier way of doing it. And copybooks are absolutely the right answer. If you look here, you will see I have a copybook. Come on.
Not found.
It should be. I know why. Oh dear. Sorry. I didn't set my library list properly. So I've got to get that there. Now, I sit here and I prepare and I prepare and I prepare, but I don't actually, oh, there it is. What I do is for every IO server that I create a copybook that looks like that. So I encompass all of that because it is absolutely consistent. And just to make life even easier, in the template generator, there is a template for it, which you can generate using the template generator exactly the same way as you generated the IO servers. And it gives you all the details and fills in all the file names and does it all for you. No problem at all. So that is how, whoops, I've done something wrong here. That is how I managed to create simply and easily. So when I create an IO server, I use the template generator to just create the copybook that goes along with it. Then all I have to do is to include it in my program, and I can remove all of that code. And I define my IO server with one statement. So that statement gets replaced by what is on the left-hand side, on the right-hand side here. And so when I want to use an IO server, I just include its copybook, and the definition is complete. Makes it simple and consistent all the time. Okay. Any question on that score? The copybook substitution and everything else you understand all right? I'm going to get my face off here. I'm tired of seeing it.
I have a question regarding the logical file.
Yes.
Within the same program, if we are using, the physical file or maybe one other logical file, there's an issue with the record name because actually within our program we have to rename, the record name. There's an issue within with using this kind of setup.
No,
about the record name or not?
All you would do is you would, in your IO server, you would do the rename of the file.
Of the record format. Okay.
Yeah, you would do it inside the IO server because that is where your FSpec is.
Mm-hmm.
And that, of course, is then where your rename will take place. But as far as this is concerned, this is only a name. It's a data name.
Mm-hmm.
And it just, for consistency, I like to do it this way because then I know what I'm looking at. Doesn't matter whereabout in the program I come across it.
Okay.
All right. By the way, I have this little trick, which you might be interested in. I break my code up into sections like this. And they all begin // ampersand. So if I do that and select it and I filter selection, basically I've got my program in all sorts of little pieces and I can open them up one at a time. So those are my IO servers. It just makes longer programs easier to handle. Okay, then we have data definitions, of which there are none for my test program. And then we come to the main line. Now, this is not an extremely complicated program. I have to admit that. And it doesn't work very well because somewhere along the line, prod orders got records but prod from IP7 has lost all its records. So prod IP7 is empty. So let's see what happens here. Now, this is a new activation group. This is where things, you've got to keep your head together on these things. Once you get used to them, it's easy. But if everything is new for you guys, activation groups and everything else is new. So I won't blame you if you say, huh, what's going on? Because I'm starting a new activation group. Remember, an activation group is a resource management group. And one of the things that it manages is commitment control. Commitment control is bound into an activation group. So, because my IO server, now let me find my IO server, just so that I can, because my IO server declares a file and I've got it under commitment control. All IO servers should be opening commitment control unless you have a specific reason not to do it. But because using this IO server, I will be using it under commitment control, I have to start commitment control every time I get into a new activation group, because the commit cycle is held within an activation group. Does that make sense? Are you with me?
Okay. Yeah.
I'm watching the avatar heads nodding, and there's none that are shaking.
We believe you, Tommy. We believe you.
I don't like that.
But it makes sense.
Yeah. So because the IO server always does commitment control, and really, this is a direction, this is a policy that you've got to look into as for the future, because commitment control is one of those heavy lifting functions that the database can do for you, making sure that you don't have half-completed transactions in your database. So you should commit yourself to commitment control fully. Okay. Yeah, that I just thought of that. That's quite clever. Right. So the first thing you have to do in the program that starts a new activation group is you have to start commitment control. Now that command is a call to this procedure here. And it says, execute the command, start commitment control, start change. That's it. Completely standard. It happens in every one of my programs that starts a new activation group. If you don't do that, you will get an IO error when you attempt to access the service program, because the service program will say, you're trying to access a file opened under commitment control, but the commit control is not active. Right. So that's that. Now, the next statement, do while not. Now, here is where the function is powerful as opposed to the procedure. Remember what I said? The function returns a value. And in the case of this IO server, it returns an indicator. And it returns an indicator for different reasons. One of them is when it hits end of file, it will return an on condition, an indicator 1. And just to make absolutely sure, we're going to do a read forward. Where does it get read forward? Here. Read next. See, this is the read RF here. So this is the read, where the second one is a forward. Read next. record and return end of file indicator. Now, that will be either a 0 or a 1. Because your function, your function is returning a value that can be used as part of a conditional statement. Which is such fun because it makes life so simple. Do while not in the file is what that thing says. It says do read forward one record while you are not at end of file. So it has to execute that first to get a return value, and then it evaluates the condition. Any question?
No, interesting.
A very, very powerful feature. In fact, any function that returns a value can be used to place that value in any expression whatsoever. I'll show you some more of them later. Right. Now, because I've done this, read forward one record, and I've used ORD P, I passed ORD P to the IO server. The IO server has returned that record that it's just read into that record in my definition. So prod ord R is a data structure that now contains the first record out of that file. You agree? You're happy? You understand that? Going slowly. RF says read forward, read the next record into the word record, into the data structure record. We'll go back up here to record. And record is based on prod ORP, which it got from this P, which it got from that P, which it got from there. Did you follow that?
Yeah, I did, but
you're going to have to look at it again.
well, it's
you see,
yeah.
I when we talked about pointers, I said be careful of these things. They are powerful as anything. They can be used to address spaces that you really don't connect to. And this is the whole chain of events. This program defines in here, defines a field called ord R, and P is the address of ord R. So I have defined a space in this program here, this test program I'm doing. I've defined a data structure which is called prod ord R. There it is there. Well, I'll tell you what, let me go here. I've defined a data structure called prod ord R. There it is there. There's a standard declare statement, which means that this prod OOO, which we're looking at, contains a data structure, which is the product record, the prod ord record. I then make P equal to the address of that. In fact, I do that at initialized time because this is an INZ keyword here. So that pointer points at this from initialized time. So it's always that pointer is always addressing that space. Now remember what I said to you? A pointer points at the first byte. of a space. So that pointer is pointing at the first byte of that data structure. And that data structure exists in this program here. It's physically defined within that program. When I do this and I execute a call to the data structure, to the IO server, I mustn't do that. I'm passing it that pointer, which is the pointer to that space that's here. I receive that pointer as parameter P. I've given it that name because it's short and easy to write. That's the value that's contained here comes in here. I then move this P, which is the same pointer, I move it to prod ord P. Now this is not the same prod ord P as this one. This one is defined in this program there. So I have made this pointer equal to that pointer. Okay. Now this record is based on that pointer, which is that pointer, which is that pointer, which is the data structure in this program. So this record actually overlays the data structure in this program. Let that sink in a little bit.
Yep. Because the pointer is into the memory. So
Yes.
if both programs are pointing to the same pointer, you are at the same place.
You're at the
so
same place.
Yes. You have two programs dealing
Which,
with the same memory space.
it's defined, it exists here, but
Yeah.
this program is using it.
Yes.
You like pointers yet?
That's really cool. That's really cool. It cannot be any faster than this. You're pointing to
No.
the same.
You're not moving
memory.
anything. You're not moving anything. This is where this takes, you don't have to move data from one place to another. You don't have to duplicate memory. You don't have to do any of that sort of thing. You just point to it from somewhere else.
Yeah, you're sharing the same memory altogether within programs.
Exactly. And it gets better, I promise you. There's much more you can do with this stuff. But I'm glad you got, is everybody on the same page, or are you going to make sure they're on the same page, Bernard? Francis, come on. You're an old man. Are you on the same page?
I'm not sure about one thing. I'm trying to understand. If you look at to call the procedure $, I've got two parameters, RF and $P on the left side. And within the IO server, I have 4 parameters. Is indicator.
You've got 3. You've got one parameter there, which is equivalent to the RF. It's the first parameter.
Okay. After that, this is the pointer.
P, which is the pointer.
And where is the two other?
K is the key. Okay.
Okay.
But
where I pass the key when I'm calling the porter, I don't have any key.
It's
optional.
I don't have to pass it. I can leave it off.
Okay. This is why for the Premier P7, I've got 3 parameters.
Yes. Sometimes for some actions in the IO servers, you will use the key. and some you won't.
Okay.
I'll show you now where you use the key. All right. So because it's optional, I don't need to define it on that call because I'm reading one record forward, one record. I don't need a key. The IO server is designed to just read the next record.
How does it know that you have to do a set lower limit first? Because normally before to start a read circle, we are doing a set lower limit.
I'm reading the whole file. I'm reading from record number 1. So this call will take me in to that statement.
Okay.
If it's not open, which it won't be, I will open the file, and that will position the record pointer on record 1.
Okay. Then you don't have to do a set lower limit in this case.
No.
Okay.
You don't need to. But here's where we get something interesting. Look what I've done here next as a statement. I've moved the NOCOM that comes from order, prod order, and I've moved it into prom IP7K. The key for prom IP7K. Okay. Now, here's another little bit of a mind bender. I could have written it like this. I could have written it like that.
But I think that the name of the field is not the same for both files.
That is the problem. Because you guys have used prefixes in your naming convention for different files for the same field, you can't get away with that.
For these cases like that. But for many other file, it's
that's why my recommendation has always been one data item, one name used in all files. Drop the prefix. But you're not going to do that. I'm not saying anything. Because that's a major change. But I'm just illustrating that you could, you see, doing it this way, even if I had 17 keys in the file, I could do it with one statement. Because I haven't, because I'm using different field names, I would have to write 17 statements in here if I had 17 keys. Follow me?
Yep.
So let's just delete that one out of the way. We don't want to confuse the issue. What I've done is I've moved the NOCOM key across to the prom IP7 key. Now I know prom IP7 has got 2 keys. I don't care about the other one because my next statement is calling the prom IP7 IO server. Which I'm trying to find the source code for just now, by the way.
He's going to read all the record for this command, within prom IP7,
Yeah. So this one is now, I'm making a call to prom IP7S, IP7 But I first want to set the lower limits using only one key. You follow me? I want to set the lower limits to the NOCOM.
One mean the first field of the key.
First key.
First key, okay.
Yeah, first key. And if you look at this code, make this a little bigger just so that it's easier to see. You see there, S, go to the set lower limits. Now here, if A2 is blank, you set lower limits with a full key, right?
Yeah.
If A2 is L, You set lower limits on start, i.e. low. When A2 is H, you set lower limits to end.
Mhm.
Anything else, I convert the number of keys to a numeric. Sorry, yeah. Integer. I convert it to a numeric. And then I say, when the number of keys is 1, set lower limits on the first
one.
key only. Okay. Now I know there are 2 keys, and my IO server knows there's 2 keys. That's why this IO server was generated with 2 keys. Of course, S2 and S are the same. Okay.
Yeah.
And then the error handler will throw out this particular IO server error. If it's anything else, it'll say you have requested an invalid action, because it's not coded. So it returns an error handler, an error to the caller to say this is an invalid action. So what I've done here is I've set the lower limits, and notice here I put a null in the parameter where the pointer is usually, because I don't need the pointer to set lower limits. I don't need access to the record to set the lower limits. I need the key, which I put in as the third parameter, to set the lower limits. Make sense?
Yeah.
Right. Then, having set the lower limit, I do while not read next. Do while not read next. Where is it? Read. Where's the read? Hit read here. Get. This is the read. Read next. Returns get next. Go to get next. It says when the number of keys is 1. Notice I'm using the number of keys value that was set by the call S1. So it's reading, read next, save key 1, using your record into the record. So what that's doing is it's populating the structure record with the first record from that key data structure. Any questions? I think I'm going to have to do this again. I've got a feeling about it.
Oh, me, you know, I understand, but I don't do the programming. So, but where's the record data structure? Okay, there's a record up there.
The record up there, which has a pointer, which is in fact it's exactly the same as previously. Yeah. Okay. Now, this is interesting here, because if you look at the get next procedure, when keys is 1, which is what it is, because we set it to 1, if you remember, it reads next. But it's only using the 1 key. So what am I reading here? I'm reading a block of records which match that first key. Are you comfortable, guys? Francis, are you comfortable with what you're seeing there? Okay. So if I get, and then I read a record which is not got a matching key, what happens?
Well,
it returns an end of file, doesn't it?
End of file. Yeah.
It's not truly an end of file because it's not an end of file, but it's the end of that record set. Agreed.
Can you, Tommy, can you go at the top of the IO server? I just want to see if how you declare the file somewhere, I think.
There's the file declaration.
Okay, then it could be update, delete, output. It could be all of you can do with
Exactly.
IO server.
It's
Okay.
fully, this is a fully functional IO server. So it
Then
allows you to do
my
everything.
question is, when we only have to read, then we don't have to lock a record. Then in
That's
the case that you read a record, do you specify the N mean unlock within the read or the chain?
Well, in fact, if I'm doing a read, I always specify, where am I? I always specify
The N
no
unlock.
lock. No lock.
No lock. Okay.
Unless I'm doing a read for update,
Yeah. The
in which case I
okay.
don't.
Okay.
Okay. Because remember, you can only update on a full key.
Mhm.
You can't update a partial key.
Yeah.
Okay, does that make sense?
Yep.
Now again, because I'm doing exactly the same trick again, do while not that situation, I will get the function returning me a 1 if I've got to the end of that record block, of that set of records, or a 0 if I'm not, if I found a record that matches the key, the lower limits, okay? Then, of course, I would execute a procedure and do something. I haven't done anything there. I've just put in an empty procedure because obviously you would like to do anything that you want to do. You might, for example, want to do an update. You've read a record and you might want to do an update on that record that you've just read. So what would you do?
Instead of RN, it's going to be a code to say that I need to read but not unlock. Then it will be R with another letter. And after that, I'm going to recall from EP7 with a update action.
I'm going to do an update.
Update, but before instead of RN, it's going to be RN. I don't know the
no.
N is not lock.
Read next. Read next.
Read next. Next. Okay.
Read next is always following, because you're reading next of the group which you set. So read next will always follow a set lower limits.
Okay. But in the case that you have to read and also not lock, then he will do only read on not lock, or I have to
no
to specify.
You don't need to do anything, because what I would do here, let's say I don't know what the let me just see the add. Let me do you see the other advantage of using PROMIP 7P 7R full stop. RDI, when you're using qualified data structures, you type the name of the record and RDI pulls up all the field names, which is very useful. And I can get that. Okay. Let's just assume that I'm going to add 1 to that counter. I haven't a clue what it is, and it won't break anything because I don't have any records in this file. I lost them somehow. So let's assume we're going to add 1 to the counter, and now we're going to do an update. All right. That's it. That's all you need to do.
Then does it mean that the U will do a read and after an update?
Right, let's look
Do
at this.
both?
We get a U, right?
Mm-hmm.
So we go to the update subroutine. The update subroutine will do a chain on the
Okay.
full key. On the full
Okay.
key. Now, this is where the trick of the IO server comes in. If you look up here, if the parameters equal 3, i.e., if there are 3 parameters coming into the IO server, you have provided the IO server with a key structure, okay? Therefore, I move the key parameter into the file's key. But if it's not 3 parameters like it is here, it's only 2, I will move the record corresponding into the key. So what I've done here is when I don't provide a key, I take the key value out of the record and place it in the key structure.
Yeah.
Make sense? So that when I come down to the update, that field, that key structure, has got 2 keys in it. So it's 2 keys, which are the keys for this record that I just read up here. I then chain to that record, but I put it into the save record. I don't overwrite the pointer record, the record. Because if I read it into the record, I would be overwriting this change that I've just made. Would I not?
Okay.
I'm chaining to that format, but I'm putting it into the save record structure. You'll notice that in all IO servers, there's a save record structure, which is like rec, the record format. There's a save key structure, there's a key, save key number, and there's a save pointer.
Okay.
Does that make sense? So
Mm-hmm.
my update is chaining to that key, but it's chaining the record into the save rec area so that I don't overwrite what is in the record structure pointed to by the pointer. Then if I found it, I update it. And I return the found indicator. If it's not found, and A2 is an I do the put routine and insert it. When A2 is blank, or anything else, there are error conditions that are returned as error messages to say, nah, can't do that. It's not valid. So this little exercise would read the record set from the first record and add 1 to the counter, and it will go through the whole file, adding 1 to that counter for every single record on the PROM IP7, essentially.
Okay. Question, Tommy?
Yes, please.
Let's say on P7 file, there's a before trigger, and then it triggers a problem when you try to do the update.
Okay.
So
Thank you. We're going. This is coming, but I'm glad.
okay. Okay.
No,
I'm going to leave it
I
to
want you to see it here as well. That update will fail because the trigger says, no, I have returned an error message. That update fails. The next statement that will be executed is not this one. It's this one. because an error has occurred in the monitor group. So it'll jump from that statement to that statement. And of course, this error handler is O3, which moves all the diagnostic messages and resends the escape message. So this escape message will cause this procedure to end and return to its calling procedure, which is this one. And this procedure will have ended with an error. So it will drop straight through to that condition because there's now an error from the procedure that was returned here. I cannot do anything else. I drop through to the on error condition. And that ends this procedure, which is the mainline procedure, will end with an error. So this O3 will move the diagnostics and resend the escape message to here. And this, because it encountered an escape message, will drop to there. And because that encountered an escape message, it will drop to here. And because that encountered the escape message, it will move the diagnostics and exit via an escape message. This program, being the first program called in the call stack, will then terminate. And the error message that came all the way from the trigger program will appear on the message line on the screen that you issued the call from.
Okay.
That's where it'll come up. You will have had a command line here to issue a call to that program, and the error message will appear there. Because that happens automatically. You don't have to do anything. If you see how that percolation was happening? It bubbles up from the procedure that creates the error, and it goes up through all the procedures. And none of those procedures need to recognize the error or do anything about it. They pass it right out. And what you will see here is error in trigger program XYZ. Or, depends, if you've got a client app with this 5250 screen, you will need to handle that error message and put it on the screen in a user-friendly manner. So none of these procedures or programs in this pipeline need to understand what the message is all about. They just pass it on to somebody who can deal with it. Does that answer the question?
Yes, yes, yes.
I have one more question, Tommy. Where
Please.
will you do your commit or your rollback? Within the main program, or
Right.
for each update, or only
No.
at the end of the program?
What is your transaction boundary? Because that's what you've got to get into your head. You've got to understand what your transaction boundary is actually. Where is the transaction boundary? Now, in this little program, I'm going to say that the transaction boundary, you can see here, I read forward one record on the ORD file. I then process a record set for that NOCOM, i.e. I do that and I do something which is that, and I'm going to consider my transaction is complete for each record I read off the PR prod ORD. That would be, in this particular case, I would choose that as my transaction boundary. Okay. So where I would do that would be actually to put the commit in here.
Okay.
Because once I've finished processing that record set, I will do a commit before I go back and read the next prod record. But it is important that you identify your transaction boundary. You see, It could be that you're updating 12 different files
Mm-hmm.
and you want to make sure they're all properly updated before you do the commit. But there's one other thing you've got to do here. Or not,
It's
depending on how good you are at handling this
Yeah.
thing. What's the opposite of commit?
it's rollback.
Right. So what happens if I'm halfway through doing this block of updates
Mhm.
and something goes wrong? Now I've updated 5, I've got 10 more to go. I need a rollback. Where do I put it?
Then whenever you roll back there.
There's one option. You can put it there.
Okay.
So you do the rollback there. But, and this is something you've got to watch out with activation groups. You've got to be very careful about activation groups in this sense.
Mm-hmm.
Because I'm in a new activation group here, and I have received an error. I remember I'm going to move the diagnostics and I'm going to resend the escape message. Now, resending or sending an escape message out of an RPG program automatically terminates that program. It's equivalent to a return, but it occurs at exactly the same, at the point at which you send the escape message. The program gets terminated, the call stack entry gets ended, and the call moves up one level in the call stack. Now, because this is a new activation group, i.e. it's a system managed activation group, I wonder whether you can remember back this far. What happens when a system managed activation group ends?
He's doing normally a rollback or a commit.
First, any uncommitted updates get rolled back automatically. And secondly, all resources get recovered, shut down, and released. Those are two things that happen when you exit a system managed activation group. So actually, in this particular case, I don't need that rollback.
Because the it will do that.
It will do that
At
automatically.
the end of the okay. In the case
Yes.
that he found an escape message. Okay.
Yes, exactly. Notice something else here. There's no set on LR and there's no return in this code. I don't need a set on LR because I have got a linear main line. So I don't need to set on the last record indicator because it helps me nothing at all and it does nothing. I don't need a return because once again, this is the main procedure in a linear main line. And when I hit that statement, the program ends. So the program will end either on end proc or on that one, depending on whether it's an error termination or normal termination. So I don't need to write those codes into the process.
But you need to do a commit. Because if you forget to do a commit, what will happen at the end of the
you will lose
process?
you will lose all the updates. Because when the program ends, all those commits that have all those changes that have not been committed will be rolled back.
Yeah.
So the commit is to fix the changes. And you've got to know what your transaction boundary is. It could be one record. Often it's just one record, and then you commit straight away. Very often. But if, for example, you're loading a bill of materials, you've got a header and you've got a whole lot of material entries, which make up the whole bill. When you are entering these into the database, your header is in one file and your bill of material entries are in another file. You certainly do not want half a bill of materials to be accepted into your database. So you would only commit once the full bill of materials has been completely updated satisfactory, then you would do the commit. Otherwise, you would do a rollback, or you would exit the activation group and let the rollback happen automatically.
Yeah.
So, right, let's have a look. So this is essentially how you handle an IO server. You'll notice that there's one line to define the IO server, and there's one line for each action you want to perform on the IO server. And the IO server does the rest of the thinking for you. Let's just go through some of this. The first time you call an IO server, it will open it for you automatically. You don't need to do that. It, of course, splits the action code up into 3 pieces. And it moves the pointer into the pointer so that you have you are referencing the right piece of data structure in the other program. If the 3 parameters, I load the key into the key structure, otherwise I load from the record into the key structure. I can get away with this eval corresponding. I can get away with that because they're the same record, and therefore the field names are the same, even with the prefix. The key data structure and the record from the same file have the same prefix. So I can get away with that eval corresponding there. But let's have a look at some of these. I is put. U is update. D is delete. S is for setting lower limits. G is for setting greater than. Just one thing about this IO server. This is my IO, all function IO server. I built this years ago and I've refined it, and it does most of the IOs that I ever need. So it doesn't mean to say that you are locked in to doing it this way. Please understand that. This is code you can write. But I would suggest that if you do change it, make sure you test it properly, because it can bite. G is set greater than. R is a read, which is in a get subroutine. These two I very seldom use. PS, save the current position in the key, current key. So it saves the key, number of keys, and saves the key of the current record and returns on to say I've saved it. PR is reset to last saved position. I reverse that process, set greater than, return on. So this is just, if I want to save the position because I want to read somewhere else in the file, or I want to read another record from somewhere else with a different key in the same file, I can save where I was and then go back to it later when I continue processing. Okay. So I very seldom use it, but I put it in there for fun. Then this has evolved, and this is why there are 2 values in here. At the start of this whole process, I used X to close the file. Then I decided that X is stupid, C is better, because C stands for close. So I've got either X or C does the same thing. It closes the file. Anything else kicks back this invalid instruction. Operation not supported is what it says. Right, let's have a look. The put procedure. Write that record from that record. Return on. Not a very, very complex piece of code. A simple write instruction. Using that record, which is actually not there, it's over here. But use that record and write it out to that record name. Update procedure, chain, because you always have to chain before an update. If it's found, update it and return found. If it's not found, you guys are comfortable with the select when, eh? Clauses. That only one of these when conditions is ever executed. That's what I'm getting at. Are you comfortable with that? Because sometimes people get confused as to, if it's found, do that. If that's an I, why are we doing that if it was found? It doesn't execute. So it only does one of the when conditions in a select in select clause. I find them very useful and much more friendly than nested ifs. So that's the update. It either updates it, returns it, goes to put if it's an update insert, or it throws it out and says, excuse me, but the update failed for some reason. This iOS 3000 is update failure, and this one is invalid action. The delete procedure. Now, this one I have serious debates about all the time. If the second key is, the second action is blank, I'm going to use the whole key and chain to it and delete it. So in this case, I'm deleting one record whose key matches the one that I've provided. That's it. Return found. So chain, if found, delete it, return found. Simple. However, if the number of keys, if it's not a space, I move whatever's in the second position into the number of keys, because now I'm deleting a block of records. And if the keys are one, I chain and I loop around that delete, and I'm deleting everything from key 1. If keys are 2, I loop around there, I'm deleting everything from key 2. This gets a bit tedious if there are 12 keys. But unfortunately, and I have contacted IBM about this, but they haven't changed it. This value in this parameter, in this chain, the key data structure, can only be a numeric value. It cannot be a variable. Which means if it was a variable, I would put number of keys in there and I would have no problem. But it is a number, so I have to do this when it's a nuisance, but that's what it is. Of course, the get procedure gets next, gets previous, reads forward, reads backwards. And remember, it's reading next from the current pointer, read previous from the current pointer, read forward from the current pointer, read backwards from the current pointer.
Diane.
Sorry?
Yeah,
Yes.
I have a question.
Yes, Diane.
Yes. At many places, you have the return keyword, and after that, sometimes you have like a procedure or return found or return something.
Right.
What does the return do?
Okay. In this case, the return is in fact an exit from the procedure. But if you look at this procedure in its declaration, you will see this procedure is actually not a procedure, it's a function, because it's returning a value. It's returning an indicator. So the return is a statement which allows me to exit this procedure, and that is the value that I am returning in that field. So I'm returning the end of file indicator in that indicator field. So this is a way of getting out of a procedure and passing something back to the calling procedure. You'll notice that, what's that? That was the get procedure. The get procedure, come on. Where is it? Yeah. The get procedure, I use here read next. And I return, and this again, Bernard, is another way of using this call to a procedure. Because this is a function, it will execute this function and it will return the value from that function. So it will return whatever was returned from that procedure. And that goes back because that is an indicator. So that bubbles that indicator up to the top end where you see here, if you set lower limits, I return set lower limits. I return the result of the execution of the set lower limits function. And so it goes back to the calling program, and I can, if I want to, use it in a condition like I do here. But I don't have to. Update also returns an indicator, but you will notice I'm not using that indicator here. I don't have to use it if I don't want to. But I put it in all the procedures, so there's always a return from an IO server if you need it. Does that answer the question, Diane?
Yeah.
Yeah. That says, yeah, maybe.
No, but the if function is, I think it's quite new. Okay, we have to get used to it. Like return put, return put. It's the function put. So you got to go to the put procedure, and then you're gonna see what's in there.
And you will see the put procedure also returns an indicator. So whatever in this case, it's returning an on. It's unconditional on. Why? Because if that write fails, I will end up here, and I will have an error returning. So the indicator says I successfully wrote the record. But then if I send an error message back, I know that I have unsuccessfully written the record. So I've got a belt and braces here a little bit. But there are some of these return conditions, like, let me see, like the set lower limits, the get next. I want this indicator because I'm returning the end of file indicator. Now I use that. I have to use that in my set lower limits. Yeah.
Yeah.
You follow? Because I need to know whether I'm actually read a record or whether I've hit the end of the file.
But Tommy, if you only want to do a chain within your main program, I mean, then you're going to call the IO server with the, for example, R. Yeah. And when you come back, you will do if found. What will be the code? You know, for example,
if you do an R, you would get a read. Okay.
Yeah.
Now it goes to your get.
Yeah, I understand.
Okay.
But when you return to the main program,
yeah,
after calling the IO server,
right.
how do you check if you found the record or not. Would you
Okay.
do if found or?
No, you would say, I'm with you. I understand what you're saying.
Anyway, it's in
yeah.
this case, instead of doing
You would
update,
say,
you only want to
you would say, for example,
you only want to chain or to do a read for a record, for example.
so I want to read for a record. Okay. There.
Yeah, only read one.
Now I want to read, in this particular case, I need all three,
The
three parameters, because I need to provide a key. Okay. And come on. What are you doing now? I get so lazy. I don't want to type. And then when it does something like that, right.
Yeah.
So obviously I would have to set up the key. So here I would set key in whatever manner I have to. Okay. Then I would do a read. Now, if I wanted to find it, I wanted to know whether it was found or it was not found.
Yeah.
Okay.
Yeah.
My read is going to chain here, and it's going to return the found indicator.
Yeah.
Which will either be a 0 or a 1. The only two values it can be.
Yeah.
What I would do here is I would simply say, if I want to do something based on whether I found the record or not, if no. This is where it gets smarter. Okay.
I'm asking this question because I know that we will do a lot of this kind of.
So if the result of that execution of that function is a value on, remember on is equivalent to a 1 and off is equivalent to a 0. I like the on off because it reads better. Then if it is, it means I found the record, so I can fill in or execute another subroutine or do whatever I like.
Okay, in this case, then on that means it's found the record.
Yes.
Okay.
And of course, if you want to do something different when it doesn't find a record.
Okay. Okay.
That's the sort of process you can use for it.
If on, I means found, else not found. Correct. Yeah. Okay.
Because the indicator comes back differently. For example, in the read, in the get procedure, in the get next, it's an end of file. In the read, it's a found, if you're reading one thing. So it could be an end of file there as well, you see. So the indicator means different things depending on which procedure in the IO server you're using.
Yeah. I understand that. We tend to do while it's end of file that I'm looking for, but in the other case for a read, it's I'm just
that's the way you would
want to be sure that he found a record or not. Okay.
Yeah.
Okay. Give me the good response. Thank you.
If I told you to go away and write a program to test this IO server, would you be able to do it? Yeah, you're going to sit with the recording, I know, and you're going to crib. But that's okay. I don't mind.
I have another question.
Yeah.
What about your do while not prodor RF prodor pil?
That one.
Yeah. If he gets in a file, you don't have to put something like in the other one for a P7, you said you put a asterisk on at the end. There, you don't have to say end of files.
No, because this do while is a condition. That is a condition. Do while not something. What I would read this is do while not. If you wanted to, you could do while not star on. Okay. But star on comes from that procedure because that procedure returns a value of on when it hits end of file. So when the compiler compiles this, it first evaluates this function. And the result of that function is used to evaluate the condition. So this thing here can evaluate between there and there, can evaluate as either a naught or a one. Okay. Once that has been evaluated, then the result of that procedure or that function call will then be put into this expression, and the expression will then be evaluated. So this will either return a naught or a one, and if it's not one, not on.
So if he gets an end of file, there will be a 0, a 1?
No, a one. If you look at the get here, get next. Here's the get next. If you are reading a block of records, or this one is reading forwards. So it's reading forward here. There you will see read a record, return the end of file indicator.
Okay.
Now, if it is end of file, it will be a one. So this actually would be equivalent to saying do while not end of file.
Okay.
This is evaluated, and the indicator will return either a naught or a one. Does that make sense? This is, you see, this is where I was guilty. I've worked with this for so long that this is not strange to me at all. But I do realize on thinking about it how completely strange it must have been to you. But these are shorthand ways of writing much cleaner, much faster RPG. Wonder whether I can compile this thing. Have I broken anything here? I don't think so. Let me see. Can I compile it? No, compile. How's that? Right, I'm going to do something with this. I'm going to start a debug on this. Oh, that's unusual. It's already Tuesday and the debug server hasn't been started. That's unusual for me. Now I'm going to call this program. I can't do that until I edit my library list and put ABC train in the library list, which you can't see me doing, so that's fine. Then I'm going to call It's here called PRODOO. I'm going to call that. Now, if it works as it's supposed to work, it should stop me there. So it's got a system active and it stopped me dead. And it's now busy opening the debug. And there is your debug pointer sitting on this IO server here. Oh, sorry, not on the side, in this program. It's on the beginning, the declare procedure statement at the beginning of the main line. Now, I can step through it. It will do a start commitment control. And then do while not. I'm going to step into this thing. And you will see it's now stepped into the IO server here. If it's not open, it will execute the open routine. It splits the action up. So if you look at this here, action is now split up into 2 characters. Here, there's no key. The palms is not 3, the palms is 2. So you will step here and you will move the whole record into the key. So there's nothing in the key at the moment. Now there's a 0 in the key. Not surprising, seeing I didn't put anything into it. Now we're going to read forward. So it'll go down to the read. And we step into the get. And it goes past all of these until it gets to the forward. Now, if you look at the record here, it is empty. If I step through that and I look at the record here, it's now got a record in it. It's the whole of the first record in the file. And I return end of file. But end of file at this point will be off. So on that return, it take me back to the end of the get procedure. Because I'm doing a return, it doesn't do any of this. The rest of this, it goes straight to the end of the procedure, goes back again to the end of the main line, and that returns back to that particular position. Now this has got a value in it now. Which I can then move into the key, so that has the same value in it. Now, as I said, I lost all the records out of this file, so this is not going to find anything.
Are you able to see all the content of the record for the OR?
This one, yes.
Yes, but only the command. Okay, but you can see.
I can monitor the expression.
Okay.
And then if you look at the monitors, I'll bring the monitors across here. Where are we? I put it there, I think, yeah. You can actually see the contents of the record.
Okay. Okay.
So that's how you look at the contents of all the records, is you just simply highlight the record name and you can use this monitor expression and it'll show you the whole data structure. Okay, so because I have no records in this file, if I step into this, now I'm going into the other IO server, which is this one here. And it's not open. So oh, it was open. Must have opened previously. it's read next. So I put the record in. So what I've got in this key is nothing because there was nothing in the record. Because I'm doing a read. Oh, this is a set lower limits, isn't it? Where am I? No, I'm doing a read. Go there. Read next. So I'm trying to read next. But the number of keys is 1. I read the next record and I return end of file. Now this end of file takes me back to there and it drops me into the end do. It did not execute that because it did not find a record and therefore this end of file came through as 1. And there's my commit, which of course at this point is I've done nothing, so committing does nothing. I've done no updates, so committing does nothing. And then I would go back and I would read the next record. Now the current record is 4406. If I read another record, it's 4407. So that's how you debug your I/O servers to make sure they're delivering what you want them to deliver. And you can write updates, inserts, all the different types of things. Now I know, please, I've given you a template. You've built from the template. I know that template works. Because I've been using it for close on, I don't know, 20 years or something ridiculous like that. But I ask you to make sure through the debug process and the test procedure, can you please make sure you understand the code, because you might have to change it. Remember, I've been developing AO and I've been developing other types of systems for many years using these IO servers, and they satisfy my needs, but they don't necessarily satisfy your needs. So you might, at some point in time, want to change them. Please make sure you understand the code, because the code is issued free of charge, but without warranty.
Okay. It's not a lifetime warranty, Tommy?
No. My lifetime, not much longer. No,
How would you test the error handling? It's mean that you need to, in this case, just to trick the data, just to test the error.
yes.
Yeah.
It's a little more difficult to test the error handling.
Yeah.
If you don't have a trigger program that's recognizing and throwing out errors.
Mm-hmm.
Are we still on for Thursday, Marinus, Bernard?
Yes.
Good.
That's the answer.
Because you will know a lot more about triggers, and your homework for this session is to look at this program and try and understand it in a bit more detail. But your homework for after the next session will be to build triggers on these 2 files, before triggers on these 2 files. And then you can start testing your IO servers and testing the error handlers by actually deliberately entering invalid data. And then you will be able to debug the whole thing right through the trigger, see the trigger pick up the error and how the error percolates back to your program, which hopefully will be based on the one I've spent 2 hours talking to you about. Okay, I'm not going to move on to the next topic because I don't think that would be smart with only a few minutes left. So I'm going to cut this one a little short and leave you with a big question mark if you want to ask a question. Any more questions?
No question for me at this time.
Not for.
Think about this.
That's okay
Have a
for me.
look. Yeah, have a look at this. Have a look at the video of this. I'm sure, Marinus, you can get it to me in this today. Hey, it comes through.
Not today. Microsoft seems to be a little bit slow. It will be tomorrow morning,
All right.
my time, which means first thing tomorrow for Bernard and his team.
Okay. Use it. Just go through this. I know this is a new ball game. The whole thing is new. This is the problem. It's not only the code, it's the way the errors percolate backwards and the way you've got functions sending stuff back and how you can use them in expressions and all sorts of lovely things. And just get comfortable and try and calm down, because I have to say to you, I've got more coming. The next thing is pulling the DB2 trigger. We're going to start talking about actually coding triggers and what you can put in them and how you can deal with them. And this is, I've got templates, but this is a lot more you than me, I'm afraid, because I don't know your database. And as a result, how you validate and what you validate is entirely up to you. I can give you some guidelines, but no more. So enjoy your day.
Tommy,
And,
can I make a suggestion from the sidelines?
yeah.
Because from what Joel shared with us right at the beginning, he coded a solution.
Yeah.
My recommendation, if Joel feels like it and the team feels like it, why don't we stop the recording and we ask Joel to show us what he were able to do? Because I think there might be a lot of value in terms of just cementing what we've gone through today. But that is only if Bernard and Joel feels up to it and feels there will be value in it.
Well, maybe Joel's got question about what he did so far.
Well,
absolutely.
And yeah,
I can show you my code.
all right.
Okay. Well, let me stop the recording. Or do you want it to record it? It's up to you.
I think maybe we should stop the recording.
Okay.
This is not exactly for public consumption, I don't think.
No, it's not.
I'm going to stop the sharing, and you can share your screen with me, Joel.
But Tommy, you can stop it and restart a new video for